discuss about this. One second. Yeah, today we'll discuss about this overriding and method task. So, overriding methods. Overriding methods are we can call as tasks. Overriding method or task. Okay. Suppose example, if you take class, parent class, parent class. I'm using task drive, okay, and edit task, okay. So parent, I'm giving for the parent class, I'm writing the object for the parent class, parent underscore class, p underscore h, that is equal to new, and child class, I'm writing the object for child class also, child underscore class, c underscore h, this is equal to new, okay, new, and how to assign the child class to parent class by using a keyword called extend. The class child underscore class extends, okay, extends parent underscore class, okay, and I'm calling the task. So task drive, okay, task drive, and I'm writing some piece of code and end task, okay. So here, you see this p underscore h dot drive, and dot drive, okay. So here what I'm doing, parent, this is nothing but parent class method, okay. I'm calling a parent class, okay. So this is nothing but parent class method, and next if you consider c underscore h dot drive, this is child class method, okay. So if I'm writing like p underscore h, that is equal to c underscore h, okay. So what is this? This is nothing but parent handle, and this one is child handle, okay. So here what I am doing, I am assigning the child class to parent class, okay. So I'm assigning child class, so child class to parent class, okay. So if we try to assign this parent class to child class, we will get a compilation error, okay. We'll get a compilation error, we'll see with a program also, okay. So if I am trying, so that means if we try to assign the parent that means parent handle to child okay, parent handle to child handle, okay, parent handle to child handle, we'll get a compilation error, okay. Handle we'll get a compilation error, okay. So that means here so this is allowed, okay, assigning the child class to parent class, this is allowed. But if I want to assign this parent class to child class, okay, So parent class to child class, okay. So this one is not allowed, okay. So this one is not allowed. You get a compilation error, okay. This one will not allowed. This one will be not allowed, okay. We'll see with an example, okay. So let's see this. 1 second. So overriding. So here what I am doing. So class parent class. I'm initializing the this int a. So 1 second. Not casting. Casting. Okay, this one first. Hmm. This one. This one. So class parent class int a and int class. Okay. So that I'm assigning the child class to the parent class. I need to use the keyword called extends. Okay, class child class extends parent class. And in this I'm initializing one more variable int b. Okay, int b and int class and module tb. So parent underscore class p underscore h. I'm initializing the handle for this parent class, and similarly I'm initializing the handle for this child class, child underscore class c underscore h initial, and with the help of this handle I'm creating the object. Okay, here what I am doing, I'm assigning the child class to the parent class. Okay, so when I try to execute, okay, so what I will get will see. Okay, so assigning the child class to parent class, it will allow. Okay, but assigning parent class to child class, it will not allow. Okay, so if you want to see this, the breakdown, just if you copy this, if you run this, yeah, it means it is what it is processing without any error. It is processing. Okay, suppose I will comment this and I will try to assign the parent class to child class. Okay, I'm trying to run this. Okay, I'm getting an error. Okay, error incompatible type set assignment. Okay, that is child class state underscore class and parent underscore class. Okay, so that means from this I can conclude that we can assign the child class to parent class, but we can't assign parent class to child class. Okay, so this is one example. Okay, so 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 here I can write. So that means suppose if we are writing p underscore h equal to what, c underscore h. Okay, so that means you are indirectly parent class is behaving as a child class. Okay, so indirectly, so we are assigning, when you are assigning, so indirectly what happening, the parent class is acting behaving as a child class. Okay, in this case the object is pointing to the object is the in this case parent object, whatever the parent object is there. Okay, parent object is pointing to child object, child object. Okay, child object. Okay, so indirectly parent class handle is behaving as a child class handle. Okay, so indirectly, so that means here this is what this is parent class handle. Okay, this is child class handle. So here parent class handle. Okay, parent class handle is directing to child class. So indirectly what happening, so whatever the parent class handle is there, this is behaving as a child class handle. Okay, so so how you drive this method, that means p underscore h dot drive. Okay, how you drive the parent class by using this function, we can by using this task we can drive this. This is pointing the class drive method, only we can call the parent class. Okay, so this is a parent class drive method, nothing but parent class drive method, parent class drive method. So we can only call this parent. Okay, by using this, we can only call this parent. Okay, so if you see one more program related to this, child class, if you see this program, so class parent underscore class int a. So here, what I can use means there is a concept called polymorphism. Okay, so I will tell you that after this we'll see the program. That is polymorphism. What is this? So that means when you are trying to access means assign the parent class to child class, what you are getting the compilation error. Okay, so there is a concept called polymorphism. Okay, polymorphism. Okay, so polymorphism. Uh, so in this polymorphism, what happens? A handle working as a parent class as well as child class. Okay, so in this polymorphism, a handle, whatever the handle you are using, okay, handle working as parent class, as well as child class, as well as child class. Okay, child class. Okay, so here, suppose if you are normally you are using p underscore h equal to c underscore h, and you are using this p underscore h dot drive. Okay, drive. Okay, so this is not achieved. This is not achieved. Okay, so what you need to use? You need to use a keyword called virtual keyword. Okay, what is that keyword? You need to use virtual keyword. You need to virtual keyword. Okay, so we can use this virtual keyword with the methods. Methods means what? We can use with functions or we can use with tasks. Functions or tasks. Okay. Uh, so 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 here you are using virtual keyword, no? So keyword, virtual keyword. This virtual keyword that is in parent class, it is mandatory. You need to use mandatorily in the parent class. But in the child class, it is optional. But in child class, it's optional. Okay. So that means here what happening? Parent class is acting as a child class. Okay. So whatever the parent class is there, parent class acting as a child class, acting as a child class. Okay. So so how I can write the program? Suppose you will see here class parent class parent. So I'm using a keyword called virtual function function void display display. Okay, and I'm writing some piece of code and end function. Okay, and next how to assign this child class by using a keyword extends, no, child extends parent parent. Okay, function void display display. I'm writing some piece of code. Okay, and end function and end class. Okay, so like this I can write. Okay, so here so that means parent. So I need to use a handle, no? So parent p underscore h. Okay, I need to give a handle. Okay, and child, suppose child I'm using two child classes, C1 underscore H and C2 underscore H. Okay, I'm using two handles. P1 underscore H. Okay, P1 underscore H equal to what? New. Okay, and C1 underscore H. C1 underscore H equal to new. C1 underscore H equal to new. Okay, so P1 underscore H equal to C1 underscore H. Okay, so this is allowed. This is allowed. Okay, you can assign the child class to the parent class. Okay, so this is allowed. Okay, so so that means here, so this is also allowed. That means C2 underscore H equal to C1 underscore H. Okay, you can assign one child class to another child class. Okay, so this is nothing but we call as object assignment. Object assignment. Object assignment. Okay, this is allowed. This also allowed. This is allowed. Okay. So here, if you see the program related to this, which one? So parent class two and polymorphism. Okay, this is polymorph. So here, what I am doing in the polymorphism. So class, parent class, and int a, okay, and end class. Okay, this is the property and a class. So how I'm extending this? I'm initializing to the child class means class child underscore class extends parent class int b end class. Okay, and a module. Okay, so I'm using the hand for parent as well as child by using p underscore h and c underscore h. Okay, initial begin p underscore h equal to new, c underscore h equal to new, and I'm initializing. Okay, this is polymorphism. Okay, this will work. Okay, so I can initialize the parent class with the child class. Okay, it will work. So if you copy this, just if you see in the EDF window, it will work. Yeah, it will work. Okay, and the next example to this is 1 second. I'll do this. Yeah, this one. Mm, here. So class, parent class, I need to use what I told you, no? You need to use a keyword called virtual. Okay. So virtual, that is, we can use a virtual for this parent class as well as child class. Parent class is mandatory, but child class is optional. Okay, we can use or we can't use. Okay, that is your wish. Okay. So parent, so class, parent underscore class. So this is the property in the virtual. So I need to use in the method. Okay, method. That is function, virtual function void drive dollar display from the parent class end function end class. Okay, and here also I'm using this. So how I'm getting the child class by using the extends keyword. So class child class extends from the parent class into the virtual function void. Okay, display from the child class. Okay, end function and end class. Okay, so class is over, and I'm creating two handles for parent as well as child. After that, I'm writing the object for the parent as well as child, and whatever that child is there, I'm assigning to parent, and after that, I'm calling this drive method. Okay, by using drive method, I'm calling this parent class. Okay, so if you copy this and if you execute this, so what will get is so run this. So you got that means here when I am calling this, it is displaying from the child class. Okay, so that means what a parent class is. So child class is assigned to parent class. So when your child class is assigned to parent class, indirectly parent class is handled is behaving as a child class. So when parent class is behaving as a child class, so that means when I am calling p underscore h dot drive, so automatically it is going to where child class and it is executing the function and it is displaying from the child class. Okay? It is displaying from the child class. Okay? So this is like virtual the use of this virtual. Okay, and next child class, parent class, we already seen polymorphism. Caching of units. Okay. So what is the conclusion? So conclusion we can see. We can see. So what is the conclusion? Conclusion means. So we see the conclusion. Conclusion. We if we assign handle of same class, no issue. Okay. So if we assign we assign handle we assign handle of same class, no issue. No issue. Okay. If we assign handle of different class, compilation error. If we assign handle of different class means what? We can't assign parent class to child class, no? So different classes. Okay. So you'll get a compilation error. You get a compilation error. Okay. Compilation error. We can assign child class handle to parent class handle. Okay. So we can assign we can assign child class handle to parent class handle. Okay. So that means how we are assigning p underscore h equal to c underscore h. Like this you can assign. Okay. This will take. It will be allowed. Okay. So this is about this. So so there are some cases are there. So what are those cases? We'll see. Okay. Uh, so here case one. So if you see the case one, p underscore h. This is equal to c underscore h. Okay. So this is allowed. This is allowed. Okay. Uh, c underscore h2. Okay. Equal to p underscore h. Okay. This is what one child type. Okay. This is one child type. Okay. This is another child type. I told you know it will. So it will point to the parent class will point to the child class. Okay. This is another child type. Okay. This is also allowed. Okay. And case two. Case 2, c underscore h1 that is equal to c underscore h2. Okay, this is also allowed. Two child classes are there, so we can assign c underscore h2, the child class, to another child class, c underscore h1. Okay, and c underscore h2, this is equal to p underscore h. Okay, this is not allowed. Okay, so we can't assign a parent class to child class. Okay, so uh, so here p underscore h equal to c underscore h1. Okay, uh, so then what happens? P underscore h is acting as a child class. Okay, it can be used as a child class type, Okay, so c underscore h2 that is equal to p underscore h. Okay, so this is also allowed. Okay, so this is nothing but what child class handle, and this is child class handle since it is pointing to the child class object. This is nothing but what this is a child class handle. Why it is child class handle? Since it is pointing to the child class object. Previously we have seen, no? So pointing to the child class object. Child class object. Child class object. Okay. So what is the conclusion? So that means we think that it is correct, but compiler will assume that p underscore h as a parent class object only. Okay. So that means our conclusion when you are pointing this child class to parent class will point to the child class object. Okay. So we will think correctly, but what is the conclusion? So conclusion is here. we think it is correct, but compiler will assume that. So we will think, okay, we will think it is correct, okay, it is correct, okay, it is correct, okay. But what the compiler will assume? Compiler will assume that p underscore h is a parent class, okay, parents class handle. Compiler will assume that this is a parent class handle, okay. So for making this, we need to use a concept called, we already came across, that is nothing but casting. What is this casting? Okay, so we already discussed this topic. So there are two types of castings are there. What are those? One is static casting, and next one is dynamic casting, static casting and dynamic casting. Okay, so in this, what we are using means we are using so static casting. Okay, so here when it will happen? So static casting will happen during the compilation as well. Sorry, compilation time. Okay, static casting happens during the compilation time, whereas dynamic casting happens during the runtime. Okay, during the runtime it will happen. Okay, so whatever we are dealing with parent class and parent class and child class. This process is happening in which class, in which time? That is happening during the runtime. Okay, that is happening during the runtime. So as this is happening during the runtime, we need to use which class, which casting? We need to use dynamic casting. Okay, so we need to use dynamic casting. Okay, so what is the syntax? We'll see. Okay, so we need to use dynamic casting. Okay. So why we are coming to the dynamic casting? We'll assume that when parent class is assigned to when child class is assigned to parent class will point to that child class object only. That is our assumption. Okay, we'll think that, but the compiler will understand that p underscore h is a parent class. Okay. So what is the syntax? We'll see. That's why we are going for the casting. Okay, syntax. So what is syntax? Dynamic casting. So $cast uh, dst destination underscore handle comma sr underscore handle. Okay, sr source underscore handle. Okay, so here what I can use $cast c underscore h2. This is destination, and what is the source of p underscore h, p underscore yes. Okay, so now you can convert parent class handle to the child class handle. Okay, by using this syntax, we can convert parent class handle to child class handle. Parent class handle to child class handle. Okay, so we'll see with one example. So if you see this one, this is casting. Okay, so this is a simple program. So here, what I did, you see here. So class parent class, this is the property and virtual function. So we are I'm calling, that means here I wrote so I extended this child class to parent class, and I'm writing the function for this one. Okay, int b and int class. Okay, so I'm writing for the handle in the module tv initial begin, and I'm writing the object, and I'm assigning child class to parent class, and I'm calling the drive. Okay, and so drive in that. Okay, so this is one type of casting. So if you execute this, copy, and once if you paste this, you run this. Okay, okay. This casting tool. Okay. So here what I'm doing. So here class parent class, and this is the int a. I'm initializing this property virtual. So virtual function void drive. So this is from the parent class. Okay, this is the way from the parent class end class, and I'm extending this parent class to child class and int b. function void drive. This is from the child class. Okay, this is the method from the child class and end class. Okay, and I'm writing two handles, parent class p underscore h child class. Two child classes are there. Okay, c underscore h1, c underscore h2. Initial begin. I'm writing for the object. Okay, this is upcasting. Okay, so upcasting means what? I'm assigning the child class to parent class. This is legal. Okay, it will work. Okay, so I'm calling the parent class. Okay, what it will display we'll see. Okay, direct call using the child handle also I can use. So c underscore h1 dot drive. Okay, if you are using casting. Okay, so casting I told you know if dollar cast destination and source. Okay, c underscore h2 comma p underscore h1. This is downcasting succeeded. Else display downcasting is failed. Okay, so this is like casting. By using casting, by dynamic casting, we can make this child class to parent class. Okay, we'll see this. Okay, so just I'm copying this, copy this, and paste in this. Run this. 1 second. What is happening? 1 second. So here so that means here what happening? So upcasting is nothing but initializing c underscore h1 to parent class. Okay, I'm calling this parent class. So that means it is calling from the child class. Okay, so it is calling from the child class, and also I am directly calling this child class. Okay, this is also from child class. Okay, after that what I am doing from the destination. So what is the destination? P underscore h1. I'm assigned to child class. Okay, and I'm displaying. Okay, so I'm displaying means what? This is working. Okay, dollar cast. This is working. Okay, the casting down casting is succeed. So now we can use this parent class as a child class. Okay. So this is like by using casting we can use. Okay. We can use for we can assign the parent class to child class. Okay. So this is about the basic overriding functions and overriding tasks. Okay. Overriding methods are tasks and polymorphism and dynamic casting. Okay. I hope it's fine. And next we'll start the new concept that is randomization. What is this randomization? First, randomization. So randomization. So suppose like example. So class. Suppose if you take class test int a int a. I'm using range 3 is to 0, 3 down to 0. P. Okay. End class. Okay. And initial begin initial begin t underscore h dot a. Okay, equal to I'm giving 50. Okay, t underscore h dot b t underscore h dot b handle I'm initializing to 100. Okay, so here what I'm doing means basically in the SV system Verilog. So basically I need to develop. Suppose this is a design. This is my design. Okay. So in this there is a design. In this design, I need to develop a test bench. Okay. I need to develop a test bench. Okay. So why I am developing a test bench to verify that my design is correct or not. Okay. My design is correct or not. I'm developing a test bench. Okay. So uh, to check the functionality, okay, to check the functionality. So how we are checking means by generating. This is nothing but what you are giving some fixed values, okay. So by generating randomly generated values, random stimulus, okay, randomly generated values we are giving, okay, generated values we are giving, okay. So that means in the Verilog we are given some fixed values, okay, randomly we not given, okay. In the test bench also we given a fixed values test cases to the design, okay, but in this we can use random values. So for that you need to use a keyword called, so you need to use a keyword called rand. What is this rand? Okay. So by using this keyword rand, this is used in the properties. Okay, this is used in the properties. Wherever you declare this data type, no. So this data type within this properties, I can use this keyword. Okay, so this is used in the properties. We are interested in generating the random values. Okay, so we are interested in is for generating what, for generating the random variable, random values. Okay, randomly I want to test the circuit. Okay, so that is a random method. Okay, so how I can give? So see here I can give like this. So rand int a. Okay, rand 3:0. Okay, like this I can initialize. Okay, so how to prefer this randomization? Okay, so randomization means how to perform this randomization. So giving the random values to the stimulus. Okay, that to the design, and so that is nothing but randomization. Okay, so how to perform this randomization? How to perform randomization. Okay, so this randomization we need to use the to the uh, methods. Okay, to the methods we need to use. Okay, so that means for the method you need to use a keyword, a built-in function, that is randomize. Okay, so this is nothing but what, built-in function, built-in function. Okay, randomize is nothing but what, built-in function. Okay, suppose example, if you take one example. Okay, so example, class test, I'm using rand int a, rand int a. Okay, so rand int a, so that means what is the range of a? So range of A, okay, range of A is 0 to 2 power 32. Okay, so within this range, it can generate any values. Okay, randomly it will generate. Okay, end class, end class, and module TB, module TB. Okay, module TB. So I'm writing for the handy test T underscore H, test T underscore H, and initial and begin, initial and begin. T underscore H equal to what, new, T underscore H equal to new, and T underscore H equal to what, I need to use randomize, I need to use randomize. Okay, so I need to use randomize and end. Okay, so we'll see some one program related to the randomization. Hope you understood. That means here, in order to give the fixed values, here we are giving the random values. For that, we are using a keyword called rand. Okay, rand you are using. Okay, so we'll see the programs related to randomization. Okay, first example is, so example one, just class test. So random. So I need to use in the properties, no? So random bit 1 is to 0 A. Okay. So 1 is to 0 A means what? What is the range? This is 2 bit. 2 bit means what? 2 square. So 4 possible combinations it can generate. Okay. So 0, 1, 2, 3. Okay. End class module TB. And this is handle test at T underscore H initial begin. And I'm with the help of this handle, I'm creating the object T underscore H equal to new. and without any condition, no conditional check, I'm generating this randomize function. Okay, so inbuilt function t underscore h dot randomize. Okay, dollar display the value of a is what percentage d t underscore h dot a end and end model. Okay, so if I execute this, just observe what values it is generating. Okay, so just if I execute this in, I'm running this program. Yeah, see. So that means here, what is the property bit? You know, bit 1 is to 0. So the value of a is what 2. Randomly it is generated. Okay. So that means I displayed this. The value of a is percentage d underscore h dot a. You know. So randomly it is generated. Okay. Randomly it is generated. Okay. Like this, it will generate random. Okay. And next second example. Second example. So here what I am doing means. So same class test. I'm using a keyword rand bit 1 is to 0. So bit data type 1 is to 0 A. So that means possible combinations are 4 possible combinations and module TB, and this is the handle. And what I'm doing first, what I will do, I will use see here. I will come. I will use. I want to generate these words 3 times. Okay. So initial begin. So this is the what this is the by using this handle I'm creating the object, repeat for 3 times. Okay, begin. Okay, t underscore dot randomize display this value. Okay, so just I'm seeing this, just you see what values it will display. So I'm copying this, I'm running this program. See, so that means here the value of a is 2, the value of a is 1, the value of a is 3. Okay, randomly it is generated. How many values it will generate? So 1 down to 0. So 1 down to 0 means 2 bits. Okay, that means 2 square. 2 square means 4 bits it will generate. So randomly it is generating. Okay, suppose if I want to generate like 10 bits. Okay, just this one I'll remove comment, and this one I will comment. Okay, this one I will comment. Okay. So here just I'm copying this, and here just I'm pasting. Okay, run this. See, so that means what you observe, that means here it is generating the random values from where to where, from 0 to 4. Okay, the value of 2 is 2, the value of a is 1, and the value of a is 3, and after that it is 0. So it can repeat. See here, it is repeating. So here 1 is there, again 1 is there, again 3 is there, 3 is repeating. Randomly it is generating the value. Okay, randomly it is generating. 0 is also repeating. Okay, so that is nothing but rand. Okay, that is nothing but rand. Okay, so I can write I can write what is this random function. Okay, so mm, so what is this so rand. Okay, so rand is nothing but variable values uniformly generated over the range. Okay, okay, so whatever the variable variable values uniformly generated over the range Okay, one more keyword is there, that is nothing but rand c keyword. Rand c keyword. Okay, rand c keyword. So what is rand c keyword means? C means what? It's like a cyclic one. Cyclic. C means cyclic. Okay, rand c. Okay, so what is this rand c? Uh, so random cyclic variables that cycles through all the values in a random combination of their range. Okay, so this rand c, random cyclic variables. Okay, that cycles through through all the values, all the values in a random random combination of their range, combination of their range of their range. Okay, so if you see the example, that means here uh, if you use we already see no rand 1 is to 0 rand 1 is to 0 a. Okay, so how many possible combinations? Four possible combinations are there. Okay, four possible combinations are there. Suppose if I repeat, okay, I'll use the keyword repeat for 4 times. Okay, so how it will, so that means here, it will generate the random sequence, but it can repeat. Suppose one it will be generated. After that one it will zero it will be generated. One it will be generated. After that one it will be generated. One it will be generated. Okay, so that means here it can repeat. Okay, it can repeat. Okay, so suppose same thing if I am using rand c. Okay, 1 is to 0, some bit 1 is to 0, here bit is there, 1 and c. I need to use bit with respect to property, no, the bit 1 is to 0 a. Okay, four possible combinations are there, and you need to use repeat, let us take 4. Okay, so how it will generate? So that means it will be not repeated, but in rand A it can repeat, but in rand C it will not repeat. It will generate 1, next generate 2, and generate 3, and next 4, again cyclic, like this also. Okay, it can't be like means it can't be like an up counter, just like 2 will be generated, next 1 will be generated, and 0 will be generated, and next 3 will be generated. After that again 2 will be generated, like this. Okay, so that means in case of rand C, all possible combinations will be covered. Okay, so you see, so that means four possible combinations means from 0 to 3, all possible combinations are covered, and those are not repeated. Okay, so the repetition of the values will happen after reaching the combination. So that means when the repetition will happen, so 0 will be started after completing all the combinations. Again, it will start from the repetition. Okay, so that is nothing but rand C. Okay, so we'll see the example related to rand C. This is example. So if you see the rand C, yeah, this program. So here what I'm using, I'm using class tester. I'm using two properties with what this is one more related to rand. One second. Example type. Okay, rand C. Okay. Okay. Here, what I will do, I am initializing two variables, that is A and B. One I am giving as a rand, and next one I am using as rand C. Okay, so this A is the property, so bit A. So this I am using for rand, and next this one using for rand C, and module TB, and I'm initializing a handle, and I'm creating the object. After that, I'm repeating. Okay, so repeating by how many times? Repeating for 8 times. Okay, begin t underscore h dot randomize. Okay, and display the value of a, and after that end. Okay, and again repeat 8, begin t underscore h dot randomize. Okay, and display b value. Okay, just to we'll see and try to understand what is the difference between rand and rands. Okay, so just I'm copying this, I'm pasting this, I'm running this code. Okay, separately I wrote for separately for a as well as separately for b. Okay, so if you observe here, the value of a, so the value of a from here to here, okay, it is repeating. Okay, it is repeating. So here 3 is repeating, and here also 3. You are getting 4 values, but 3 is repeated. Okay, 3 is repeated so many times. But if you see the cyclic randomization, what happening, like here if you see 4 combinations you got. Okay, it may not be serial, 1 you got, 3 you got, 2 you got. After that 0 you got. Okay. After that what happens? The cycle is over. Okay. So after completing the cycle only this cycle will be repeated. So 3, 0, 2, 1. Okay. This will be repeated. Okay. This is the difference between rand and rands. Okay. Hope you understood. And next is mm, pre-randomized and post-randomized. Okay, what are these pre-randomized and post-randomized wheels? Okay, so pre-randomized and post-randomized. Pre-randomized and post-randomized. Okay, so that means here we need to use a function called. So that means you need to use a function void void. Uh, you are using a keyword pre-randomize, pre_randomize, randomize. This is these are built-in functions. Okay, these are nothing but built-in functions. Okay, and you can use function void post underscore randomize Uh, so this is the function. These are nothing but we can call as built-in functions. Okay, built-in functions, built-in functions. Okay, so if we declare pre or post randomize inside our class, we are what we are doing means we are overriding. Okay, so when we are declaring so here right, if we declare if we are declaring uh, pre and post randomize inside our class we are overriding we are overriding them. Okay, overriding concept also we got. Okay, overriding them, this is very much important, overriding them. Okay, so here how we are writing t underscore h dot randomize randomize. Okay, this is this will point toward pre-randomize pre_randomize and post_randomize. Okay, so that means pre-randomize when it will be done, pre-randomize will be done before randomize and post.randomize will be called after randomize. Okay, so that means it will be done before randomize. Okay, before randomize. This will be done after randomize. After randomize. Okay, after randomize. Okay, so related to this, we'll see one program. So pre-randomize and post-randomize. Okay. This is my program. See. So, so here what I did like, mm, so I'm like a class tester. So I'm using two properties, rand bit A and rand bit B. Okay, function void pre-randomize. I'm using a function void pre-randomize. Randomize is going to start end function. Function void post randomize. Randomize is completed end function and end class. Okay, module TB and I'm using this handle. With the help of handle, I created the object. After that, I'm repeating. Okay, for how many times? 8 times. Okay, within. So I am calling this t underscore h dot randomize. Okay, randomize means what? Before randomize. Okay, so the value of a is percentage t underscore h. Okay, so when I am calling this, what it will be displayed, we'll see. Okay, so this is not I am not using. Okay, just this one I am removing this. This I am not using. Just copy this and we'll see in the EDF window. Yeah. So if you see in the EDF window, run this. So see, so it is generating 8 random values. Okay. First, randomize is going to start. Randomization is completed. Okay. Value of A is what? 2. Okay. Again, randomization is going to start. Randomization is complete. The value of A is 3. Like that. So like that it is generating. Okay. It is generating. Okay. Here means rand I used. No? So I can use rand. So rand, if I am using rand means it can be repeated. Suppose that if I am using here like rand C, okay, I am using rand C, okay. Rand C, I think B is not using. A I'm only using A. Okay, B I am not using. Okay, just I am comment this and I will see what is the output. I am getting different values. Okay. See here, randomization is going to start, randomization is complete, and the value of A is what? 1. Okay, after that. So it will be, so like 4 random values you get, and that will be not repeated. After completing the 4 random values only, again, it can be some random sequence. Okay, so this is a pre-random and post-random. Okay, so, so here I can write the cases. You can write the cases. Yeah. So, case case one. One second. Yeah. Case one. Suppose if I use rand bit 2 down to 0 A. Okay. So that means what is the range 2 down to 0? So that means 3 bits are there. So how many possible randomly generated sequence it will generate? 0 to 7. Total 8 bits it will generate 0 to 7. Okay. So that means here so condition 1. Okay. What is the condition? So condition 1. So condition 1 is example my range should be 0 to 3. Condition 1. So example my range should be 0 to 3. Okay, 0 to 3. Condition 2. Okay, uh, condition 2. Condition 2. Okay, condition 2. The value generated randomly should be even values. The values generated randomly should be even values. Even values. Even values. Okay. That means what? Randomizing variables with some conditions. Okay. Randomizing variables. Randomizing variables with some condition. With some condition. Okay. With some conditions. Okay. That is nothing but this is achieved. Uh, so we are going to use a concept called constraints. Okay. So this is one of the favorite topic for the interviewers. Okay. To achieve uh, so to achieve this randomization of variables with some conditions. Okay. So variable with some conditions. Okay. So achieve this we are going to use uh, concept called concept called constraints. Constraints. Okay. So this is one of the favorite topic for interviewers. They can ask many questions from this constraint. Okay, so constraints. What are these constraints? Constraints are nothing but a set of rules which we are going to apply such a way that randomization not happens blindly. Okay, so randomization is not happening blindly. What randomization is happening with meaningful way. Okay, whatever the randomization is there, that is happening. That is not happening blindly. That is happening through one meaningful way. Meaningful way. Okay, so that is nothing but constraints. Okay, that is nothing but constraints. Okay, so that means here uh, like if you take this is design. Okay, design and a test. Okay, this is design and this is my test bench. This is my test bench. Okay, so here how we can give the values. Two types of stimulus are given. How you are giving test cases? Okay, two types of stimulus. Two types of stimulus. Okay, so those are one is directed stimulus. Directed stimulus. Okay, directed stimulus is nothing but you are giving direct values. A equal to 0, B equal to 1. In Verilog you have seen some test cases you are using. Okay, next is randomized constraint stimulus. Okay, randomized randomized constrained stimulus constrained stimulus stimulus. Okay, so this is the randomized constraint stimulus. And next program, this is the okay. This is one more program related to randomization. This is properties and pre-randomize and post-randomize. And suppose so I'm repeating for how many times? 8 times. Okay, begin. If not of this randomize failed. Okay, otherwise it will display. Okay, just this one also I will see. I'm checking for the condition. Okay, so just copy this, just paste this. So here also it is random is going to start. So what happening here in the what I did means in the dollar display statement. So here dollar display statement I changed. That means randomization is complete. So here randomization is going to start. The value before randomization is percentage D, this dot A. Okay. Randomization is completed. The value of A is percentage D, this dot A. Okay. So this dot A I am using. Okay. So randomization going to start. The value of before randomization is 0. Before randomization is 0. Randomization is complete. The value of A is what 2. Okay. After that it is displayed. Okay. After that the randomization is going to start. The value before randomization is what 2. Okay. So that is the initial value. Okay. Before randomization that is the initial value. What is that initial value? Initial value 2 is the initial value. After that randomization is completed and it is giving some random value 3. Okay. The value of A is 3. Okay. So like that it will execute. Okay. So this is about this session. Today we discussed about the basic that overriding on the task and functions. Okay, so that overriding concept we have seen. Okay, that how we can assign the child class to parent class. Okay, and so we already seen like polymorphism. Okay, so by using polymorphism technique we can assign this child class to parent class. Okay, and that is polymorphism and casting also. Okay, so blindly we will assume that child class is assigned to parent class, but compiler will understand that p underscore h is a parent class only. So how we can assign means by using a casting. That too we need to use the dynamic casting. Okay, and randomization is nothing but we need to give like randomly we need to check the values, give the values to the design in the test bench. Okay, in the stimulus we need to give the values. For that, you need to use rand syntax, rand keyword. So it will generate random values, but values will be repeated. So if values are not to be repeated, we need to use rand c, that is cyclic. Okay. So within that number of possible combinations, that values will be repeated, but values will be not repeated. After completing that cycle, again that value will be repeated. That is nothing but RANC. Okay. And next we already seen the two built-in functions, function void pre-randomize and function void post-randomize. Okay. So this also we already seen with examples of what is a pre-randomize and post-randomize. So we are generating the random values by using certain condition is nothing but constraints. Okay. So to achieve this, we need to use these constraints. So basically, in the test bench, there are two types of it. Directed stimulus, we are giving fixed values. Randomized constraint stimulus. So stimulus, that means with some condition. Suppose I want to generate the test cases, even test cases, or test cases. Okay, increasing order, decreasing order. There I need to use a concept called constraints. Okay. So this is about today's topic.